Hello everyone, welcome back to this channel. And welcome back to the series in which we take a look at networking protocols and communication protocols in a practical manner. And in this video, we will be taking a look at the MQTT protocol. The agenda for this video will be split up into three main sections, where we first will introduce MQTT, then we will take a look at the plan of action, and finally we will implement this with a very simple demonstration. Or implement what we've learned with a very simple demonstration. The tools that we will use is the Raspberry Pi. MQ telemetry transport is a lightweight publish and subscribe messaging protocol that is used for machine-to-machine communication for low bandwidth environments. Smart sensors, wearables, and other Internet of Things devices typically have to transmit and receive data. And typically, they have limited resources and limited bandwidth in the network to do so. So they would use the MQTT protocol to transmit data and receive it, as it's an easy way to communicate IoT data efficiently. MQTT works on the principle of the publish and subscribe model. In traditional network communication, client and service communicate with each other directly, as we've seen in the NTP video, the Network Time Protocol video. However, in MQTT, that is different, as it uses a publish and subscribe method to decouple the message sender, which we will call the publisher, from the message receiver, which is the subscriber. And we will decouple them by adding a third component, which is called the message broker or the MQTT broker or MQTT server. And this broker essentially will handle the communication between publishers and subscribers. So, as we've mentioned, MQTT has three main components. It has the publisher, which publishes information or messages into channels called topics. We have the subscriber, which subscribe to channels that are called topics to receive information or messages that have been sent to that specific topic from the publishers, and we have the MQTT broker. So how does the MQTT work? An MQTT client will first establish a connection with the MQTT broker. Once there's a connection, the client can either be a publisher and publish messages, or subscriber to subscribe to certain messages, or do both. And when the MQTT broker receives the message, it forwards it to the subscribers that are interested in that message through filtering these messages into channels called topics. Let's take an example to further understand what we've just said. Let's say that we're trying to monitor the temperature of your living room. So we will have a sensor that is connected to a microcontroller that will act as a publisher, which aims to publish the temperature readings to the MQTT broker or server. And it will publish these messages or sensor readings to a topic called temperature, for example. Then our phone, who's trying to listen on the temperature readings as we are trying to monitor the temperature of the living room through our phone, would like to subscribe to that topic, temperature, through subscribing to the MQTT broker and listening to that topic and listening for temperature readings. To better understand this protocol, let's go ahead and perform a simple exercise using Mosquito MQTT server on Linux. You can either use a Raspberry Pi that's been flashed with any Linux-based OS or any Linux-based computer. You can even use a Linode server, which I have used in the past, but I will not be using in this video. Eclipse Mosquito is an open source and licensed message broker that implements the MQTT protocol. It's lightweight and great for hobbyists as it can be run on devices from low power single board computers like the Raspberry Pi to full-on servers. In order to implement this simple exercise, we will first need to install Mosquito onto our Raspberry Pi, and after installing Mosquito, we will first activate the broker, the MQTT broker, and then we will create a subscriber and publisher that both subscribe and publish to a topic known as trial. In the publisher node or aspect of the MQTT communication, we will publish messages to the MQTT broker to that topic, the topic trial, and we will observe those messages being relayed to us in the subscriber end as we are subscribed to that topic trial. So without further ado, let's go ahead and jump over to the implementation. So first thing that I will do is I will connect to my Raspberry Pi through SSH. So after SSHing into my Raspberry Pi, I will first go ahead and update and upgrade the Raspberry Pi through sudo apt update. Press yes, or write the letter Y for it to update. After upgrading and updating, you can go ahead and install Mosquito. This is what we will do over here. And after installing Mosquito, and I've already done this step, we will install the Mosquito client. So you can see that I've already have the latest and newest version. Now, to check and ensure that the installation has been successful, let's go ahead and run this command. We should see that this is active and running, and if we don't, we can go ahead and use the same command. However, rather than status, write enable -- now and write Mosquito. I won't be doing that as I don't need that. And then when you check the status again, you will be able to see that this is active. Now, one more thing. We need to make sure that we need to write Mosquito to ensure that the MQTT broker or server is set up and running. So let's simulate a subscriber node and a publisher node that will use this Mosquito broker to communicate with each other. So I will open up another terminal and I will SSH into my Raspberry Pi again. Now, if you are working on your Raspberry Pi, you just need to open another terminal. But as I'm SSHing into my Raspberry Pi, I will need to SSH through another, let's say, terminal. And in our new terminal, we will set up a subscriber node that is interested in a topic we will call trial. So to do that, we need to write Mosquito _sub. And the topic that we're interested in subscribing in is the trial topic. So this command creates a subscriber client that subscribes or listens to a message of any messages that is in the topic trial. Okay? You'll notice that nothing happens, and this is because the subscriber is waiting to listen or to hear any messages published into this channel or into this node or topic that we've just created. And so let's create a publisher that will publish messages into this topic trial. Okay, so I will need to also SSH into my Raspberry Pi. And I would need to do the same for the publishing node. And rather than mosquito underscore sub, we will use mosquito underscore pub. And we will let it subscribe or publish into the topic trial. And the message that it will publish is hello. When we go back to the subscriber node, we can see that it has received the message that has been published by our publisher over here. After sending the message hello, let's try sending another message. For instance, welcome to the topic trial. Let's see what happens. We receive it as well in the subscriber node. Congratulations! You've just set up your first MQTT server client-based communication. It's simple. I hope you found this video useful in understanding MQTT. And if you have found it useful, consider subscribing or supporting the channel through Patreon, where the link for the Patreon page is in the description below. And as always, thank you for watching.